Hello, everybody. This is Mrs. Billig. You may hear music in the background because I am at Panera, and you also might hear the baby in the background because I've got the baby with me. He's just a little under the weather today, so we're staying home. So today's examples are going to be about multiplying square roots and simplifying cube roots. So with multiplying square roots, you can just add to yesterday's notes. So the first example would be 4 square root 3 times square root 7. So one of the properties with radicals is that you can, when multiplying radicals, if they have the same index, you can multiply the numbers under the radical. So we can do 3 times 7. So 4 square root of 3 times 7 would be 21. 21 can't be simplified, so that would be your final answer. For number 2, we have 5 square root 10 times 7 square root 10. We would multiply the coefficients together to be 35, and then multiply the numbers under the radical to be 100. Or you can think about, that square root 10 times square root 10, the square root cancels out, and you just get 10. But also, square root of 100 is 10. So this would be 35 times 10, which is 350. Example 3 is negative 3 square root 3 times 2 square root 15. So once again, I multiply the coefficients to be negative 6, and 3 times 15 is 45. I know 45 can be reduced, so I would break it up into factors of 9 and 5. So this would be negative 6 times the square root of 9 times 5. The 9 comes out of the radical as a 3. So we have negative 6 times 3 square root 5, which simplifies to negative 18 square root 5. And example 4 from this part is 2 square root 5 times 7 square root 30. So I'm going to do 2 times 17 is 14. 5 times 30 is, well, actually, one of the things we can do is, I know that 30 is factors of 5 and 6. So I can write this as this 5 times 30, which would be 5 times 6. And I want to write it like that because I know that the 5 and this 5 are going to pair up and come out of the radical. So this would be 14 times 5 square root 6. And then 14 times 5 is 70 square root 6. Now, if you didn't think about that ahead of time, that's okay. You could have just multiplied 5 times 30 to be 150, and then think 150 factors of 150 that are a perfect square. And you would have gotten the same answer eventually. All right, so those are those examples. And then the next are cube roots. So simplifying cubed roots. So kind of like yesterday's lesson with the square roots, except we're looking for three pairs of 3, or groups of 3 rather, because it's a cube root now. So the first example is the cube root of a to the third, b to the third. Now, thinking about what we did yesterday, we expanded all of the exponents. So this would be the cube root of a times a, and then b times b times b. So instead of putting parentheses around 2 pairs or 2 items, I'm going to put parentheses around every group of 3 I see. So I see 3 A's and I see 3 B's. That means that the A can come out and the B can come out. So this would be A times B, or just AB. Now you could have thought about that as just like the cube root, and cubing something cancels out and you just get A and B as well. But this is how we can do it for all of the other ones too. Number 2. All of the other ones that don't have like a cubed, if it's 8 another power, such as this next example. So this one is the cube root of x to the 4th times y to the 5th. So I'm going to rewrite x to the 4th as 4x's, y to the 5th is 5y's. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5. All right, so I grouped the 3 x's together. Don't worry, Simon will make this short. And then the 3 y's, so the x comes out as x, the y comes out as y, and then we have the cube root of what's left inside, which would be 1x and 2y, so that'd be y squared. Okay, let's do 2 more. I think Simon just wants to bounce. Maybe. Okay. So the next one is the cube root of 27, a to the 4th. So 27 is already a perfect cube, so I don't need to break that up. So we have the cube root of 27, a times a times a times a. So 3 of the a's grouped together and come out. The 27 comes out as a 3, so I have 3a cube root of a. Okay, we're going to try to get through one more example here. That is 7 times the cube root of 200 m to the 5th times n. So find factors of 200 that are a perfect cube. If you think about it, it would be 8 and 25. And that would be the only thing that could work. You could just try dividing 200 by different perfect cubes, and you would end up getting that 8 is the only one that works. So I would rewrite this as 7 times, 7 times the cube root of 8 times 25, and then the m's I would write as m, 2, 3, 4, 5 times the n. So the 8's going to come out as a 2. These 3 m's are going to match up. So that would be the 8 comes out as a 2 and is multiplied with the 7, so that's 14. The m comes out, and I have left under the radical is 25 m squared times n. All right, got it.